Hi and welcome to another lecture on business mathematics. Today we are going to learn how to use Desmos to analyze quadratics that we learned last time. So let me remind you of a few things we did. We said if you have a quadratic equation, which was some number times x squared plus some number times x plus some number equal to 0, we went through the derivation. We showed that x, the root, is minus b plus or minus b squared minus 4ac divided by 2a. In addition, we said that if we have a function, a quadratic function, which is just that expression, then the x-intercepts are exactly these roots. So we can consider these things as roots or zeros. We can consider them as x-intercept for this function. Now to see this, let's go ahead and play with Desmos and learn how to draw graphs of function on Desmos and practice the functionality of this very nice software. So let's go ahead. So here I have the Desmos calculator. I pick some function and graph it here. Let's just pick something to practice. Let's suppose I want to graph or analyze. So I could be wanting to solve this equation. Excuse me. Or I might be wanting to graph this function 5x squared minus 3x minus 12. So that is the equation that gives us the x-intercept, and that is the function we are investigating. So when we are on Desmos and we want to look at these roots and such, we make a function out of our equation. We just set y is equal to that expression, and then we go ahead and see what does it look like. So step one, I come here and say, well, I had y is equal to 5x squared, step forward minus 3x, and then minus 12. I look at this and immediately I realize my picture, which is this red graph, is extending beyond my window. So you see that the bottom of this picture is whatever it is being cut, and of course this is from the top, it's going to escape anyway. So I try to improve my picture, just like when you use your phone to take a picture of your family and friends. Well, you don't want to cut somebody's feet, or you don't want to frame it in a unsatisfactory manner. So how do we frame our pictures? We are trying to convey a lot of information. Our picture has to be looking nice as part of the communication skill that we have. We want to make sure that we make a good impression and convey good information. So here is this range. The range is going to help us, as it says, we have graph setting. So we can go ahead and, for example, try to capture the bottom of this picture. And we see all of this white space here is kind of not useful. We try to reduce that. So how do we do that? First of all, I need to start from a little bit lower than this minus 5. So perhaps I need to go to minus 10 and such. Oh, sorry. Why? Now, how do we get rid of this? Of course we don't. Well, sorry for that. That was strange. So we go again here. Just don't go in that bottom panel, I guess. We set the bottom of the picture, we want to go to a lot lower than this. This is -5. I want to go lower to see the tip of this picture. So I say, well, let's, is -6, is -7 enough? Let -7. Well, -7 is not good. How about -8? That got a little bit better. -9, still not there. -10, it's still not showing the tip. So 11, 12, 13, you see that. Let me go to a nice number, 15. Uh, so I went the low end of my window, I brought it to -15, so -15 is a nice number. I can see the tip here. Now the top of my graph is at this number. If I want to make it a nice top frame, this is the top of the frame, so maybe I use 5. So my graph is extending from -15 to 5. That's my window. Now, again, this graph is a little bit narrow and I have a lot of white space here, not being all that useful. I can stretch my function. How do I do that? For example, I can go to just -5 instead of going all the way to -10. So maybe I go to -5. And on this side I go to 5. So that got a little bit better. Perhaps you want to go to 4 maybe. That's up to you. So for example, -4. If you want to be symmetric, you go to 4 on the other side. Now you look at this graph. It's a little bit better than what we had before. You remember the previous one was kind of narrow and the foot of it was cut and so on. So we try to frame our picture in a window that conveys full information and makes use of the space that we have. Next issue was the issue of finding the roots. So let's go back here. So okay, suppose I want to solve this equation. What are we supposed to do? We said x is equal to, so big fraction. So this was A, this is B, and this is C. So minus B. Remember, this is B. So minus B is going to be 3 plus or minus radical B squared. B is -3, has to be squared, minus 4 times the first number and the last number. Is that right? Divided by twice the first number, twice 5. So I clean this up. I get 3 plus or minus, that is 9, and 4 times 5 is 20, times 12 is 240, divided 2 times 5 is 10, and then I get 3 plus or minus square root of 249 divided by 10. Well, in real life, the numbers don't have to always look like friendly 1, 2, and 3. Every now and then we come across things that are just whatever they are. And then as the problems get more and more complicated, we want to be able to double check our answer, make sure we are on the right track, and so on. So here I have 3 plus and minus square root of 249 over 10. I might use a calculator or something and try to approximate what this number is. So we use our calculator and try to find approximation for this. So I see I get this is almost 1.88 if you use the plus, and if you use the minus you get almost minus 1.28. Of course you get a lot more digits on your calculator, as I just wrote an approximation. Well, the idea of using Desmos is to help us to visually see and double check our answer, make sure we are on the right track, and help us understand the situation. So here it is, we said the roots are same as the x-intercept. So I have an intercept here and I have another intercept here. So if you go ahead and just click on near that spot, Desmos is smart enough to realize that you're looking for the x-intercept. So if we said x-intercept is the intersection of your graph with the x-axis, and that's same as the root. So when I click here, you see I get that answer. I got 1 point, we got 1.88. You remember we got 1.88 here. That was 1.88. With more decimal places, if you write more accurately, you get 1.87797, etc. And that is what we are seeing here. 1.87797. So to 5 decimal places, that is what it is. And this 0 is indicating the height at this point is 0. That meaning that this expression has become 0. How about the other one? You notice that this one has a light gray dot there. It means that the software already indicating to you there's something interesting going on here. Go ahead and check it, and we see that it is showing minus 1.28. That is what we got. If you want to write it more accurately, well, you have more digits if you want. Here Desmos gives it to 5 decimal places. Desmos also suggests there are other interesting points. For example, there is this y-intercept. You remember y-intercept is what you get if you set x equal to 0. So you get y is equal to minus 12. That's intersection with the y-axis. That is a point of interest. Parabolas have lots of other interesting points as well. One of them is the so-called vertex. What's a vertex of a parabola? Well, the tip of the parabola, the point that is either closest or the furthest from the x-axis. That's the point where it turns around. That's the tip of the parabola. How do we find the tip? Let me just briefly talk about that. So sometimes we want to know the turning point of the parabola. So in an application in economics or business, sometimes you want to know the turning point of a certain phenomena. That's a point of interest. That's mathematically that's referred to as the vertex. So we can have a parabola like the one that we are graphing it. It is going down and comes back up. The vertex will be this point. Sometimes the parabolas go up and then come back down, and the vertex is going to be that point. So if I have ax squared plus bx plus c, and that is my the name of the shapes, of course, called the parabola. So where is the vertex of it? Vertex has the x being equal to minus b over 2a. That is in this formula. If you just pick without the radical, we get our x-intercept. So without the radical, we get our our vertex. The vertex is in fact halfway between the two roots that you have. If we go, where was it? We have this point, x-intercept, another x-intercept. Halfway between the two of them is a line that goes through the vertex. To see that, I say x is equal to, we said minus b over 2a. B is, so let's write it minus b is minus 3 divided by 2a. 2a is 10. That is, writing it nicely, just 3 over 10. You see, x equal to that is a line that goes exactly halfway in the middle of the parabola. It passes through that vertex. The vertex is 0.3. That's same as 3 over 10. And the height of it, you can take the x and plug it into the equation, and then that gives you your y. So So if I take these two roots, average them, add them, divide by 2, what I get is what we have, x is equal to minus b over 2a. And if we take that and plug it into our equation, y is going to be a times minus b over 2a squared plus b times minus b over 2a plus c. Now I simplify this, becomes a times b squared over 4a squared minus b squared over 2a plus c. Now one of these a's cancels this a, so I get b squared over 4a minus b squared over 2a plus c. I take a common denominator of 4a, so that is b squared. I have to multiply this thing by 2 to have the same denominator. Multiply this thing by 4a, makes 4ac. Cleaning it up, I get minus b squared plus 4ac divided by 4a. So what did we get? This is the x of the vertex and this is the y of the vertex. Let's paraphrase this thing. X is minus b over 2a. V is minus b squared plus 4ac divided by 4a. So that is the vertex of the parabola. Vertex of y is equal to ax squared plus bx plus c. Other than vertex, there's another point that is very interesting about the parabola, which is called the focus point. Let me explain that parabolas actually very common in life, in technology. In fact, in most of the houses on the roof they have, or they used to have, a satellite dish. Satellite dish is a shape made out of a parabola. If you take this parabola and rotate it around its axis, you get what is called a paraboloid. And paraboloid is exactly the shape that is used by satellite antennas. Let me show it to you. Okay, so here is a demo of a satellite dish. This one is pointing horizontally, but in general, of course, the direction that you point it to is toward wherever the satellite is in your sky. But here, just to make the problem simple, we are assuming the satellite is far to the right, and so this green dotted line is where the parabola is. If you take that parabola and rotate it around this axis, then you get the paraboloid, and that's exactly what the satellite antenna is. Now, what is so special about satellite or about the paraboloid? Paraboloid has this property that when this wave comes from a satellite, it's parallel to the axis of the parabola. When it hits the surface, it bounces so that the bounced ray always goes through the same point, and that point is called the focus of the parabola. So if I just move that pink line top to bottom, regardless of where that line comes in, it always bounces off of this surface so that it will go through this point. Presumably at this point you have a receiver, and this shape is the most optimal shape you can have for concentrating all of your wave at one point. What are the other elements in this picture? For a paraboloid, this is called the directrix. Directrix. Each point of the parabola is of equal distance from the directrix and the focal point. So that's the role that this one place. So these are concepts that in geometry, but they find application in daily life. So this is, if you look at the roofs of buildings around you, more than likely you're going to see this. Sometimes much larger ones, sometimes smaller ones, they are always out there. Okay, let's go back to the type of problems that we were solving. Suppose I want to verify that this point is what I think it is, 1.87797. What was the expression I had for it? The expression I had for it was here. Let me just show it to you. We had the x-intercept was 3 plus or minus 249 square root, the whole thing divided by 10. How do I show that on Desmos? Let's go back here. So here on Desmos, suppose I want to show a point. X of it, we said was 3 plus one of them. And for square root, I just write SQRT. SQRT, you see, square root shows up. Then I had 249. Okay, I come close this parenthesis and divide it by 10. That is 1.877, etc. We are trying to show it here. How do I show it? I said this point, this is x of some point. The y of it is 0, of course. Then, so I put the x coordinate and y coordinate in a parenthesis. This parenthesis here is not necessary. Let me just to clarify. So I put the x coordinate here, y coordinate here, and this is the notation for a point. Desmos tells me I'm going to show it to you with a green dot, and here's my green dot. So that is exactly where that point is. Previously, Desmos had calculated it for us, but here we are double checking that this is really that point. Let's make sure that this also turns out to be that other point, minus 1.2. What was the difference with this? Well, that was 3 minus. To make the typing easier for ourselves, I can go here and do copy. I can copy this thing with Control C. Excuse me, Control A. That was copy. Control A picks up that whole thing. Control C or Control. Oh, sorry. So with Control A I picked it, and then with Control let me try this thing again. So I pick the entire line with Control A, copy it with Control C, and come here and paste it with Control V. That's the same point. Now it became red. Of course, I don't want that. I just want this thing with negative. I want to subtract. So that is this other point. This is the minus 1.2, etc. That is the other x-intercept. So remember, this one was your axis of symmetry. To leave notes for yourself, you can come here, press the return, start with double quotes, and write a quote to yourself. So we can have the x of vertex, and you can also write it as axis of symmetry. So axis of symmetry, this line, divide your picture into 2 equal halves. Who are these? So I go here, press the return, and then if I want to leave a quote, I start with double quote. So I pressed double quote, and then I write something, for example, x-intercept, so plus is on the right, minus is on the left, and so on. Of course, you can investigate and get more details for the picture that you are drawing. And okay, I hope you saw how to use Desmos to get your nice pictures. If you have any questions, do bring it up. I'll be happy to help you. So for some of your exercises, I hope you get a screenshot of what you have done on Desmos and include it with your homework, and that way you can create nice pictures. Until next time, good luck and God bless.